Welcome to Math Mini Lessons. In this lesson, we're going to learn how to rewrite multiplication sentences pretty much when we have the product of a fraction and a whole number. In the last lesson, we looked at fractions, like if any fraction A and B form. We looked at the unit fraction where the numerator was 1, and we figured out how many groups we had. And we noticed that there was a multiple there, like whatever that numerator was, it told us how many groups there were. Today we're going to look at some equivalent fractions, meaning we're going to make sure that both expressions have the same amount. So as we're working today, I want you to look to see how I rewrite a multiplication sentence with a multiple and a fraction. Again, where our numerator is 1. I want you to notice how I use factors. This is super key important to find the missing number in the equation, to find that blank that makes it true. And then we're going to prove that both multiplications are equivalent when we multiply them out. Let's go into our first problem. Write an equivalent expression. So I want both of these to be equivalent to each other. Fill in the blank with a number that makes the equation true. So what number here would make this equation true, meaning the expression on the left has to be the same as the expression on the right. So what I'm going to do here is let's actually simplify one of them out to just see what we're coming up with. And on the right side, we have 8 times 1/5, which would be 8 over 5. Because again, all I'm doing is putting a 1 as my denominator and multiplying across to get 8 over 5. So what number, now that I have this, let's use some of our fractional thinking. Our denominators are already the same, so this makes it easier. So what number can I multiply here? Can I put into this first blank? That would give me 8. Because my denominators are the same, I know that this denominator has to be 1. Okay, it has to be, because 1 times 5 has to give me a product of 5. So now I just have to use my fact family to go what times 2 makes 8. And that we can figure out. We know that answer would be 4. 4 times 2 makes 8. So my blank has to be 4. 4 times 2/5 is the same as 8 times 1/5. And what I want you to see and notice is because our denominators are the same, I'm just thinking of these products over here. 8 times 1 is 8, and 4 times 2 is 8. So you're really going to think about some factors here as you're working through the problem. But I would always start by simplifying the expression that you have. All right, that was a lot. So let's hit pause and just jot this down into our notes. Here's our second model problem. We want to know which equation is not true. So again, we want to know that both expressions on the left and the right side of the equal sign have the same value when we simplify them out. So let's actually try with the first one first. And so for A, we have 5 times 3/4 is equal to 15 over 20. So I'm already getting tons of red flags here. One, because I noticed that my denominators aren't the same. So in order for me to have 20 as a product, I would need to have a 5 over here, because 5 times 4 would make 20. So this A absolutely cannot be true. Just because I have a 5 here, it doesn't mean that I'm multiplying both of these numbers by 5. This is 5 whole, so it has to be 5 over 1. And that makes this not true. So, oops, we're looking for the one that's not true. So we know A is the one that is not true. Let's look at the other ones and see why they actually are true. And we'll verify. And hopefully this will help us see some of the patterns again, because I know there was a lot to process before. So here I have 4 times 2/5 is equal to 8 times 1/5. So let's simplify both of these out. On the left, I have 4 wholes, so 4 over 1. 4 times 2 is 8. 1 times 5 is 5. And on the other side, again, I'm going to put a 1 here. 8 times 1 is 8. And 1 times 5 is 5. So yeah, these are equal to each other. Let's look at C. Now we know we were looking for one that was not true. For C, we had 3 times 5 over 6 is equal to 15 over 6. So luckily, the one on the right is already simplified, so we just have to simplify the expression on the left. Here we go, because I have 3 wholes. 3 times 5 is 15, and 1 times 6 is 6. So yes, 15 over 6 is equal to 15 over 6, so that is true. So that's why we're crossing these out. And let's look at the last one. We have 2 times 4 over 8 is equal to 8 times 1 over 8. So things to notice. One, we have the same denominators here. And I'm also looking at the products of the whole number and the numerator. So I know 2 times 4 is going to be 8, and 8 times 1 is 8. Why am I multiplying the whole number times the numerator? Because again, these are whole numbers, so I know they're going to have 1 as a denominator. And so when I multiply them out, I do get 8 over 8 is equal to 8 over 8, making this one also true. Alright, so I hope you're seeing some patterns here. Let's hit pause so you can jot this down into your notes. I'm also going to draw a line here so it's easier to separate the choices. Alright, here's our last guided practice for you to try on your own. Which number could be placed in the blank to make the equation true? So 10 times 3 over 4 is equal to some number times 1/4. And this has to be a whole number. So a whole number times 1/4. Hit pause and work this out. We'll reveal the answer in 10 seconds. All right, let's actually get the reveal. The answer for this one is C30. So big hints. Our denominators are the same here, and we know this is going to be a whole number. So think about the products over here. So let's simplify the one on the left. 10 times 3 would have given us 30 over 4. And the only way we can get 30 over 4 is if we would have multiplied 30 times 1/4. That would have also given us 30 over 4. All right, so I hope you're starting to recognize these patterns, and that's what once you start seeing the pattern and recognize it starts to make sense, it does go by more quickly. So get some practice in. This is probably a lesson that your parents may have a hard time understanding and may think, why does this work? And that is okay. It is okay. You're just finding new ways of expressing equivalent expressions using fractions. So why don't you just show them something new? Show them this is something that maybe they haven't seen before. And it's always really cool when a kid can show their parents something that they're learning in school that may be different. So I hope you found this super helpful, and I will see you in the next lesson, Math Marbles. Be well. Bye.